evaluating functions and how we go about evaluating functions. In other words, if I give you a value for x, how do we go about evaluating it? And it really becomes pretty straightforward, just like if you're going to use substitution. So evaluating functions is our big thing for today. Not only do we want to be able to evaluate that function, find its solution, but we also want to look at graphs of functions and find the solutions as well. So when you're evaluating functions, here's an example of what a function looks like. We've got f of x is equal to 4x minus 3, and we're asked to find f of negative 10. Well, realistically, all we have to do is we know what our f of x value is. We want to evaluate this when our x value is negative 10. And that's exactly what that means. So we go back to our original function, and anywhere we see an x value, we are just going to replace it with negative 10. So this becomes 4 times negative 10 minus 3. All you have to do when you're evaluating functions is take the value that they give you for x and replace it anywhere you see an x in that function. Then you got to follow order of operations. 4 times negative 10 is negative 40. Negative 40 minus 3 is equal to negative 43. So f of negative 10 is equal to negative 43. And that's your solution. Okay. Now, again, realistically, all of this is this just creates a point on the coordinate plane. This creates the point when my x value is negative 10. My y value is going to be negative 43. It's just creating a point on the plane. So it would just be the same thing as if we had y is equal to 4x minus 3. That's our equation. Evaluate that when x is equal to negative 10. It's the same exact thing. 4 times negative 10 minus 3 is negative 43. So our y value is equal to negative 43. Our x value is negative 10. We have the point negative 10, negative 43. It's just substitution in a different form. Now, the reason we like to do it like this is because now I can ask different things within this. I can say, okay, using that same function, let's find f of 6. Okay, so I'm still going to use this function, but now we're going to find what it is when f is equal to 6. So now instead of replacing it with a 10, negative 10, I'm going to replace my x value with a 6. So that becomes 4 times 6 minus 3, which is 24 minus 3, which is 21. So f of 6 is equal to 21. And that's our solution to these. Whatever you see inside of the parentheses that they're asking you to evaluate, you replace that with whatever value the function is. Now, it doesn't always have to be f of x. In the next one, it's h of a. It's the same thing. Okay, so now our next function, which is a new function, go ahead and write in your notes, h of a is equal to a squared minus 4a. That's our new function. And now we're going to find f of negative 8. Or we're going to find h of negative 8. So h of negative 8, anywhere we see an a, inside of parentheses, we're going to put negative 8. And it's important that you put it inside of parentheses, especially if you're going to use a calculator. Even if you don't use a calculator, it's important that you put it inside parentheses. what you're substituting in there. And then -4 times -8. Now, why is it important that you put it inside parentheses? -8 squared is -8 times -8, which is 64. If you wrote it like this, negative with 8 squared. We've talked about this in the past, but if you put it like the blue in your calculator, the answer to that is actually -64. Because with the blue one, all you're really doing is squaring the 8. So that's the opposite, or the negative, of 8 times 8, which is -64. So it's very, very, very important that you substitute, what you substitute in, you put inside of parentheses. And then -4 times -8 is plus 32. 64 plus 32 is 96. So then we can say h of -8 is equal to 96. Which again, really, in the coordinate plane, gives us the point -8, 96. So this point would be on that function, which just happens to be a quadratic. Okay. Using that same function, go ahead and find h of -10. Using that same function, go ahead and find h of -10. So h of 10 is going to be -10 squared minus 4 times -10. So that's 100 plus 40. So 140. Any questions so far with those two type? All right, so again, it all becomes about substituting in what they ask you to substitute. Sometimes what you substitute in can just give you a different expression. So if we have k of x is equal to x squared minus 4x, but now we're asked to find k of a of 3. We still use the same concept. Anywhere we see an x, we're going to replace it now with 3a, but make sure we put that inside parentheses. So this x right here is now going to turn into 3a squared minus 4, and now that x needs to be 3a. So we've got an exponent. We worked on these earlier in the year. 3 squared is 9. A squared minus 12a. And that's your solution to this. There's nothing to solve. There's nothing to go any further. You're just substituting in what's there. And it doesn't matter what's in there. I mean, I can put k of smiley face in there. And all that simply means is that anywhere you see an x, you replace it with a smiley face. So the smiley face just becomes smiley face squared minus 4 times smiley face. Okay. And that's your solution to that problem. It just becomes about substitution. Let's try one more. A little bit more complex. But again, complexity and concepts. Complexity you can do. You can do all the math. We've done all the math to do this before. The concept of being able to put it in and substitute it in is the one we're concentrating on today. The rest of it you should be able to do. So we've got g of x is equal to x squared minus 2x. We're asked to find g of a minus 3. So g of a minus 3, anywhere we see an x, we're going to put inside parentheses a minus 3. So it becomes a minus 3 squared minus 2 times a minus 3. So that's the setup. Now we just have to remember how to do the math within this. Remember, when you square something, it means to take it times itself. So that's a minus 3 times a minus 3. Minus, we've got a monomial times a binomial, so we have to distribute. Minus 2a, and then negative 2 times negative 3 is positive 6. So we're getting there. Does anybody remember what we have to do with this? What acronym did we use to do this? How do we multiply two binomials together? First times first. A times a is a squared. Outside, a times negative 3 is negative 3a. Inside, negative 3a. And last, positive 9. Now combine like terms. So we've got a squared. That gets 2 lines. 1 line, 1 line, 1 line. It's minus 8a plus 15. Overall, again, concept, you're still just replacing your x value with what they want it to be replaced with. Now you got to remember the FOIL, and you got to remember to do all of those things as well when you're doing that. Any questions so far? And those are all functions, different functions that we look at. The other way we can evaluate functions then is we can evaluate functions on a graph. What you keep in mind when you're evaluating functions on a graph, keep in mind that this is your x value in the coordinate plane. F of 2 is going to have an x value of 2. In order to find what it is, remember when we were back here, we talked about if my x value was negative 10, my y value was negative 43. So if I was going to graph that, that's like way down there. This graph is going to go through that point. So f of 2 means my x value is 2. So my x value is 2 right there. In order to find the y value, what I need to do is I need to find out where my graph, if I draw a vertical line through 2, where my graph meets x is 2's vertical line. And that's going to be my y value. So if x is 2, y is going to be 4. So this is the point 2, 4. That's the point on the graph. If the x value is negative 1, negative 1 means I go this direction 1. So I go left 1, and then I need to draw a line down to where it hits my graph. And that y value where it hits my graph is my solution. So it hits it at negative 5. So my solution to here is negative 1, negative 5. So this point is giving you your x value. This point right here is the y value. And that's what you need to find when you're looking at graphs. So if we look at this second one, if we're asked to find f of 0 on my graph, there's 0. I draw a line until it intersects. Find my y value is 4. So f of 0 is 4. My x value is -2. There's -2. It hits the graph. My y value there is 0. So f of -2 is 0. What's f of -3 going to be? I go to -3. I got to go to where my graph is. It hits right there. What's my y value right there? -5. So my y value there is -5. And again, this is my x value. This is my y value in the coordinate plane. And we're just looking for points that are on the graph. About f of 3. What's f of 3 on that graph? If I go to 3, I draw down, it's right there. That's still the point -5, right? Can you evaluate functions whether they're on a graph or written out? It's not so bad, right? Okay. This chapter deals with functions. We'll start this tomorrow.